Hi everyone. In this video, we're going to look at the 100 lockers problem, in which there are 100 lockers, 100 students, and the students go down and open a bunch of lockers. Right? The first person opens all of the lockers. The second person then closes all of the lockers that are multiples of 2. The third person then goes to all of the lockers that are multiples of 3 and switches them. So if they were open, they get closed. If they were closed, they get open. The fourth student does the same thing, but with multiples of 4, etc., etc. In order to look at that, we're actually going to look at a little bit smaller version of it. We have just 20 lockers here, but once we see the pattern, we can kind of just extrapolate that to the rest of the 100. So we have 20 lockers here, 20 students. The first student at locker 1 goes down and opens up every single locker, every locker that's a multiple of 1, which is all of them. So all 1 through 20 get opened. After that, the second student goes and they go to every locker that's a multiple of 2 and switches it. So because those are all open to start, they then close them. So all of the lockers that are multiples of 2 get closed. The third student, which is at locker 3, starts at locker 3, goes to each locker that's a multiple of 3 and switches it. So because the third locker is open, they close it. Because the sixth locker is closed, they open it. Because the ninth locker is open, they close it. The 12th locker, which was closed, gets open. 15th gets closed, and 18th gets opened. That was our third student. The fourth student will do the same thing, but with multiples of 4. So they're going to open this one at 8. They're going to close 12. They're going to open 16. They're going to open 20. The fifth student will go next. They close 5. They go to the next multiple, which is 10, and they open it. Next multiple is 15. They open it. Next multiple is 20. They close it. 6 gets closed. 12 gets open. 18 gets closed. 7th student, starting at 7, they close it at 7. They open it at 14, and that's it. Right? The next one would be at 21. The 8th student closes 8. They go to 16, and they close it, and that's it. The 9th student opens 9, goes to 18, and they open it. 10th student closes 10 and then opens 20. And for each of these next ones, they're just looking at their own locker, right? Because for the person at locker 11, the next multiple 11 would be 22, which is outside of the range we're looking at. So student 11 closes theirs, student 12 closes theirs, 13 closes theirs, 14 closes theirs, 15 closes theirs, 16 opens theirs, 17 closes, 18 closes, 19 closes, and 20 closes. So that's our result right here. So let's just think about what we're looking at. You can see the only lockers that remain open are lockers number 1, 4, 9, and 16. And you may be saying to yourself, well, 1, 4, 9, 16, those are special kinds of numbers, right? Those are all perfect squares. It's all of our perfect squares that remain open here. And we're going to talk about why that is. And to do that, let's think about the number, let's think about the number 8 for a second. Okay. So for the number 8, there are only so many numbers that go into that, so many integer values that go into 8, right, that are factors of 8. There's the number 1 goes into 8, 2 goes into 8, 4 goes into 8, and finally 8 goes into 8. So student 1, student 2, student 4, and student 8 all switched locker 8. And of course, these factors come in pairs, right? 1 times 8 is 8, and 2 times 4 is 8. So because those factors always come in pairs, those lockers are always getting switched twice. So if they start off closed, they get open and then closed again, right? You can think about this the same way for a different number. Say if we look at number 12, which has a few more numbers that go into it. 1 goes into 12, 2 goes into 12, 3, 4, 6, and 12. I'll go into 12. And again, these factors pair off. 1 and 12. That's an open and close. 2 and 6 is another open and close. 3 and 4 is another open and close. So again, because they are paired off like that, it's always going to be an open and close, and so we'll end up closed. But let's think about a perfect square, like 9. The numbers that go into 9 are 1, 3, and 9. So for a perfect square, we have this pair of 1 and 9, but then we have this singular factor in the middle there of 3, which has no pair. So while 1 and 9 will open and close it, because we have a factor that is all by itself, that is only going to open it. That set, quote unquote, of factors will only open that locker. So that is why our perfect squares will always end up open, because they have an odd number of factors.